Hi everyone, my name is Kristian Rubiano and I am a PhD student at Universidad del Rosario. Today I'm going to be presenting a work entitled 2 Decades of Land Change Dynamics Within and Around the National Natural Park System of Colombia, a Remote Sensing Approach. Habitat loss and degradation by anthropogenic land use is considered the main driver of global biodiversity decline. It is estimated that more than 80% of endangered species are threatened by these drivers. Tropical ecosystems are particularly sensitive to such threats as they harbor more than 60% of the global biodiversity and face the higher rates of deforestation. As a response to these threats, the number and extent of protected areas, the cornerstones for biodiversity conservation, has increased in the last 3 decades across the tropics from 10 millions of square kilometers to more than 20 millions of square kilometers. However, those conservation efforts are sometimes compromised because protected areas are often vulnerable to multiple anthropogenic pressures, which threaten their effectiveness to preserve biological diversity and the provision of ecosystem services. Also, habitat loss surrounding protected areas is of major concern, as they are linked to neighboring lands by key biotic and abiotic processes. Buffering regions allow ecological flows, strongly contributing to protected areas' integrity and counteracting the effects of ecological isolation. Colombia is one of the most biodiverse countries worldwide, hosts around 10% of the global biodiversity and a high number of endemic species of birds and other groups, largely as a result of the geomorphological and climatic characteristics of the region, which gave rise to complex biogeographic diversification processes and a variety of heterogeneous ecosystems. Currently, more than 50% of the country's territory is represented by protected areas. Together, all of this makes Colombia a country with an immense natural capital and a large potential for global biodiversity conservation. This natural capital faces multiple threats and anthropogenic pressures with illegal cattle ranching, agricultural expansion, illicit crop and mining as key drivers of habitat loss in Colombian protected areas and their neighboring areas. Just between 2017 and 2019, about 576,000 hectares of forest were lost in Colombia, around 8% of which inside protected areas. The end of conflict between the Colombian government and the FARC guerrilla with the peace agreement signed in 2016 raised new concerns regarding the environmental future of the country. It has been reported that this conflict had divergent impacts on the dynamics of land use and land cover change. The armed conflicts altered the underlying drivers of land use change, which simultaneously altered the intensity of the existing proximate drivers of land use change. Different armed conflicts' intensity and mechanisms can lead to deforestation or forest regrowth pathways. In Colombia, past positive environmental impacts were attributed to the gunpoint conservation influence. That is to say, the dissuasive effect of the FARC guerrilla and other armed groups limiting land use and natural resource extraction as well as impeding the development of infrastructure projects. Also, land abandonment due to forced displacement from rural to urban areas promoted ecosystem regeneration in many previously active agricultural areas. On the other hand, illicit cropping and ranching carried out by FARC for financing itself boosted deforestation in several regions of the country. These diverging impacts commonly took place in some of the more remote protected areas, such as Sierra de la Macarena, Tinigua, and Cordillera de los Picachos national natural parks and neighboring regions where guerrillas operated. Recent studies based on remote distance data have shown that since the beginning of the post-conflict period deforestation has increased, due to the expansion of productive activities and other landscape transformation drivers. Illegal cropping has increased in many regions of the country, and practices such as land grabbing and land speculation have also increased both inside protected areas and within the neighboring regions. The main objective of this work was assess the changes in landscape composition of Colombian protected areas and its buffer zones in a period of time that includes conflict and post-conflict. This study area consists of the 51 largest terrestrial protected areas of the Colombian National Natural Park System. 8 protected areas excluded from the study were either very small or predominantly covering water. Collectively, the 51 selected protected areas cover 83% of the total area of the National Natural Park System. Also, a 10-kilometer buffer around the 51 protected areas was included in the analysis. This buffer around protected areas were produced in a way that avoids buffer overlaps for contiguous protected areas. We analyzed land use and land cover for reference years 2000 and 2018. This is a time window that spans conflict, peace negotiation, and post-conflict periods, thus encompasses different and contrast moments of the war in Colombia. Atmospherically and topographically corrected Landsat Collection 1 surface reflectance were used as input dataset for the generation of the year 2000 and year 2018 land cover maps. Following standard practices, cloud-free image composites were generated for the two reference years using a temporal window expanded to 1 year before and 1 year after the target year, in order to minimize the impact of the persistent cloud cover condition affecting most of Colombia. The composites were generated by means of the cloud-based Google Earth Engine image processing tool, which allows for seamless processing of the entire Landsat Collection 1 archive. The 2000 and 2018 composites were classified separately into land use and land cover maps to reduce the potential effects of intra-class spectral variability on classification accuracies, using a 11-class scheme defined to adequately capture the land use and land cover heterogeneity of the study area. The land use and land cover classification was generated through a majority voting ensemble classification approach, aggregating the results of 5 different machine learning algorithms. At each pixel location, the class label identified by the majority of classifiers is selected, with type decided by random selection between type classes. The 2000 to 2018 land use land cover change map was generated through post-classification, by differentiating the two land use and land cover classifications, and the initial land use land cover categories were grouped into 4 aggregated classes. Finally, the land use and land cover change map was validated following standard practices, and the land use land cover change statistics were extracted. In general, based on the adjusted areas estimations in the last 2 decades, 96.8% of the analyzed protected areas' overall extension remained stable. Stable forest was the most common trajectory, followed by stable other natural vegetation. Regarding change trajectories, the most frequent were forest to productive land, artificial surfaces and to others, and forest gain. The 10-kilometer buffers were more dynamic than protected areas, as their stable area reached 92.1%. Here, stable forest and stable other natural vegetation were the most dominant trajectories. The most frequent change trajectories were forest gain and forest to productive land, artificial surfaces, and to others. This is in line with previous findings, which identified a general trend of net forest recovery at national level between 2001 and 2010. This was attributed to land abandonment for armed conflicts and economic development, which resulted in secondary forest and shrub recovery in several regions of the country. On the other hand, previous studies have identified national trends of forest loss in Colombia as characterized by the heterogeneity and spatial variability of rates and drivers of deforestation among regions. Important forest loss was also identified in protected areas between 2000 and 2015, with 82% of the Colombian national natural parks affected by deforestation and a net loss of 1.54% in the protected area system. More recently, between 2013 and 2018, in the context of the Colombian post-conflict, 79% of the Colombian national natural parks and national natural reserves were affected by the increased deforestation rates. To compare and analyze the losses of natural vegetation among forested and non-forested protected areas, this figure groups the forest loss and other natural vegetation loss into total natural vegetation loss. Overall, in the last 2 decades, the proportion of total natural vegetation loss was higher inside buffer zones than protected areas, as the comparison statistical tests suggest. The Caribbean protected areas lost on average 16.2% of their natural vegetation, followed by the Andean region, Pacific, Amazon, and Orinoco. Regarding the 10 km buffer, the Caribbean region showed the most important total natural vegetation loss, followed by Andean region, Pacific, Amazon, and Orinoco. In all regions, the total natural vegetation loss was higher inside buffer zones than protected areas. These differences can be explained by multiple regional factors that influence differentially the capacity of protected areas to counteract natural habitat conversion, and are related to the institutional capacity of the national and local governments and to different regional change drivers. Protected areas closer to human settlements located in denser municipalities with a better provision of public goods and less violent areas show with a higher capacity to mitigate deforestation. In contrast, several more remote protected areas are more prone to deforestation by expansion of illegal ranching, coca crops, and gold mining, among other indirect drivers of deforestation. The Sierra de la Macarena and Tinigua National Natural Parks experienced some of the most important natural vegetation loss in the last 2 decades. This region is a highly biodiverse area that acts as a natural corridor between Andes and Amazon biogeographical regions and allows gene flow and species dispersal, playing a major role in the origin and maintenance of neotropical biodiversity. This area also was historically one of the most important fronts in the war between the Colombian government, the FARC guerrilla, and other armed actors. For those reasons, the area is one of the best examples of the divergent effects of war on the dynamics of land use and land cover change. Deforestation and habitat loss in this area have profound impacts in biodiversity conservation, as they reduce landscape connectivity while increases fragmentation of patches and isolation of protected areas, threatening the dispersal capacities of species. These processes are potentially happening in other regions of the country and are expected to enhance vulnerability of birds and mammals, among other groups. Finally, to conclude, although the loss of natural vegetation was greater in the protected areas 10 km buffer than inside them, all the 51 protected areas experienced some loss of natural vegetation. Our land use and land cover change analysis show that both inside protected areas and in their buffers, a common change trajectory is forest gain. Forest loss trajectories were also important in the study area. Our results show difference in the natural vegetation loss in protected areas among the 5 natural regions of Colombia, and the Sierra de la Macarena and Tinigua National Natural Parks experienced some of the most important natural vegetation loss in the last 2 decades. Thank you all for listening. Do you have any questions?